Today we're going to be looking at question 3 from the Fall 2021 Exam 2. The question tells us, when input into a binary search tree, which of the following insert orders for the values 1 through 10 will not result in the worst case structure? Before we look at the answers to this problem, we're going to talk a little bit about what a binary search tree is and what the best and worst case structures are. A binary search tree results from placing each node one at a time into the left subtree of a particular node or the right subtree of a particular node based on if the value is less than or greater than the original node. For example, let's insert the number 5 into a binary search tree. Because it's the first node, it just goes right into the search tree without any comparisons. And then next we could insert the number. I'm going to put all the numbers that we're inserting at the top. Next we could insert the number 3. When we insert 3, we compare it to the 5. We say, is 3 less than or greater than 5? Because it's less than 5, it goes into the left subtree of the 5. And there is no other nodes to compare it to, so we just create the 3 node at that point. Next, we could insert the node 4. 4 is less than 5, so it goes into the left subtree. 3 is greater than 4. 3 is less than 4, so the 4 goes into the right subtree of the 3. Next, we could insert node 2. 2 is less than 5, so it goes to the left of the 5. 2 is less than 3, so it goes to the left of the 3. And so we insert the node there. Next, we could insert a 7. 7 is greater than 5, so it gets inserted to the right of 5. Next, we could insert a 6. 6 is greater than 5, but less than 7. So we insert it right here. And lastly, let's insert an 8. 8 is greater than 5 and greater than 7, so it gets input to the right, both of those. Now this is what we would call a perfectly balanced binary search tree. This is the best case scenario that your binary search tree can have, because all of the levels have the exact same number of nodes in it. The height of this binary search tree is O of log n, where n is the number of nodes that you have. This is, I'm going to mark that down, this is the best case. There's one other case that we're going to explore real quick, which is the worst case of binary search trees. Now, I want to point out that the way that we change the shape of a binary search tree is just based on the order of the values that we insert. We can use these exact same values of 2 through 8, and we can put them in a different order, and we can get a totally different structure. So for example, let's use the order 2, 3, 4, 5, 6, 7, 8, and just insert it in that ascending order. We will insert the 2 first. Next, we'll insert the 3. 3 is greater than 2, so we put it into the right subtree. Next, we can insert 4. 4 is greater than 3. Sorry, it's greater than 2, and then we look at the 3. It's greater than 3, so we put it into the 4. Next, we have 5. 5 is greater than 4. And I'm sure you'll see the pattern that each number just ends up getting inserted into the right subtree of the previous number inserted. This is a terrible binary search tree. We have gone from having an array to essentially what is now a linked list. Because of the fact that all of these nodes are just to the right of the previous node, this has height of O of n. We no longer have that height of O of log n. This is the worst case scenario for a binary search tree. It can happen from just inserting your numbers in ascending order. It can also happen from a couple different other scenarios that we'll see. So now that we understand what worst case and best case binary search trees are, let's look at the question answers and try to figure out whether or not they are the best and worst case. Whether or not they are the worst case structure. That's all it asks us. If they're the worst. So the first answer that we're looking at is going to be A, which gives the list 10, 9, 2, 4, 3, 7, 5, 6, 1, 8. We're going to insert them in that order. We put the 10 at the top. First, we insert the 9 to the left. We insert the 2 to the left of the 9. We insert the 4 to the right of the 2, because 4 is less than 10, less than 9, but greater than 2. 3 is less than 4, but greater than 2. 7 is less than 10, less than 9, but greater than 2 and greater than 4. So the 7 gets inserted here. 5 is less than 10, less than 9, greater than 2, greater than 4, less than 7. So it gets inserted here. 6 is less than 10, less than 9, greater than 2, greater than 4, less than 7, greater than 5. So it gets inserted here. 1 is less than 10, less than 9, less than 2. Inserted here. And 8 is less than 10, less than 9, greater than 2, greater than 4, greater than 7. Now, this isn't a great binary search tree either, because we don't have that perfectly balanced case. There is a few situations like with the 10 to the 9 that we're just kind of stretching out with no branching. But this isn't the worst case structure, because we do have nodes that have split off into 2 different branches. And so we're not fully maximizing that height like we were in the worst case scenario. So right now, this is looking like a good correct answer. I'll put this over to the side. We're going to mark it as A. Our next answer that we're looking at is B. B has the order 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the exact same ascending order that we had before, and so your intuition may tell you this will give us the worst case scenario, and your intuition would be right. I'm going to kind of quickly go through this. 4, 5, 6, 7, 8, 9, 10. Again, we have a scenario where every node that we insert is one greater than the one before it. And so we very quickly get this worst case scenario almost identical to the worst case scenario we had in our example with 2 through 8. Put this to the side, and we will mark it B. Next one we're looking at is C, which has the order 1, 10, 9, 2, 3, 8, 4, 7, 5, 6. First, we insert the 1. Then we're going to insert 10, which is greater than 1. Next, we insert 9. 9 is less than 10, but greater than 1. 2 is greater than 1, less than 10, less than 9. 3 is greater than 1, less than 10, less than 9, greater than 2. 8 is greater than 1, less than 10, less than 9, greater than 2, greater than 3. 4 is greater than 1, less than 10, less than 9, greater than 2, greater than 3, less than 8. very quickly we're seeing this long string of, once again, a linked list. It's just that they're not all in the right subtree of each other this time. When we insert 7, greater than 1, less than 10, less than 9, greater than 2, greater than 3, less than 8, greater than 4, and the 5 is going to end up less than the 7, 6 is going to end up greater than the 5. So we have now turned this array into, once again, a linked list format, which we know is the worst case structure for binary search trees. So both B and C right now are looking like our two worst case scenarios. Next we have answer D. 10, 9, 8, 1, 2, 3, 7, 6, 4, and 5. We start with our 10. 9 gets inserted to the left. 8 gets inserted to the left. 1 is greater than 8. Sorry. 1 is less than 8. 2 is greater than 1. 3 is greater than 2. 7 is greater than 3, but less than all the previous ones, 8, 9, and 10. 6 is less than 7. I'm skipping through a lot of the steps here just because these are getting repetitive, but for each of these nodes, I do want to clarify that you should be going through that the algorithm goes through each of these nodes one at a time. So for example, when we insert the 4, we say is 4 less than 10, is 4 less than 9, is 4 less than 8, is 4 greater than 1, is 4 greater than 2, is 4 greater than 3, is 4 less than 7, is 4 less than 6. I don't want my lack of detail to cause confusion. And then once again, 5, less than 10, less than 9, less than 8, greater than 1, greater than 2, greater than 3, less than 7, less than 6, greater than 4. So it gets put here. Once again, we have a linked list format, worst case scenario for a binary search tree. So once again, we are looking like D is not the answer that we want. Running out of room here. Thankfully, we only have one answer left to explore. I'm going to put checkboxes next to each of these to signify whether or not they were the worst case scenario, or whether or not they weren't the worst case scenario. A is the only one so far that we've seen that wasn't worst case scenario. So our last answer, E, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Your intuition may tell you this is the exact same scenario as B, just backwards, and you'd be totally right. We have a situation where each of these numbers is going to be 1 less than the previous one. And so we are going to end up with a linked list where each one is to the left subtree of the previous one. And once again, this is a worst case scenario. This is E. And so we know that then the only one of these that wasn't the worst case scenario, the only one of these that had branching, that had a node with 2 children instead of just 1, was A. So A is not the worst case scenario, and therefore A is the correct answer to this question.